Hey guys, welcome back to our channel Get Play Soon. In this video, let us see how to find the maximum consecutive ones in the given binary array. Now first, let's understand our question. What is a binary array? A binary array is an array that consists of only zeros and ones. So all the elements inside array will be either 0 or 1. Now in that binary array, we are supposed to find the maximum consecutive ones. What is consecutive? Consecutive means coming one after the other, like a sequence. Now you already know in the binary array the elements are 1 and 0, right? So you have to choose one. In the 1, you have to find the longest sequence of ones. Now let's see how to find that. In the given example, these are the binary arrays which consist of ones and zeros. Now you can see in the first array we have 3 sequence of ones. After that 1 0 and 2 sequence of ones. Which one is the longest? Which one is the maximum? 3, right? So we return 3. In the second example we have 2 ones, 2 zeros, 2 ones. So we return 2. I hope you understand the question. Now let's see the approach. Our idea is to use a simple iterative approach to find the maximum number of consecutive ones. Here in the slide you can see we are using this binary array. Now it initializes two variables. One is current count and the second is maximum count. So in the current count, we store the count of consecutive ones in the current sequence. In the maximum count, we store the maximum count of consecutive ones encountered till now in the whole array. Okay, if you don't understand, don't worry. We will look at iteration each and every step. So you will understand it clearly when we start iteration. Now you have already understood we are looping, right? In the looping, we go to each and every single element in the array. Inside loop, what are we doing? For every single element, we check. If it is 1, we increment current count by 1. If it is 0, we stop iteration. We will compare current count and maximum count and return the maximum value to maximum count. After that, we update current count value to 0. I repeat, if the current element is 1 in the array, we increment current count by 1. If it is 0, we give the maximum value from current count and maximum count and we update to maximum count and we reset the value of current count to 0. Now let's see the iteration. So the first element here is 1. So the current count will be 1. We increment the count value here. The next element is 1. So we increment the current count, that is 2. The next element is also 1. We increment current count to 3. Now we encountered a 0. So what are the values before 0 is 3 and 0. So once we got 0, we stop the iteration and we compare current count and maximum count. You can see in the left side values are values before updation. So I is at 0, we stop iteration, we compare current count and maximum count. Current count is 3, maximum count is 0. So the maximum value is 3. So that we update maximum count to 3 and we reset the current count to 0. I hope you understand. After updating, the values are current count is 0, maximum count is 3. Now moving ahead, we again got 0. In the left side, you can see the values before updation. So current count is 0, maximum count is 3. The maximum is at 3 only and current count value is 0 only. So we are doing nothing. We are moving ahead. Now we are starting the counter again. So we got 1, the current count is 1. Moving ahead, we got 0. We stop iteration and now compare. Before updation, the values previously are 1 and 3, which is in the left side 1 and 3. Now we stop iteration, we compare current count and maximum count. 3 is highest, 3 is in maximum count. Okay. Now we reset current count value from 1 to 0. So the current count is 0, maximum count is 3. Now moving ahead, we got 1. We again start the current count, that is 1. Now again we got 0. We stop iteration. The values before updation on the left side are 1 and 3. 3 is maximum and 3 is in the maximum count. We reset 1 to 0 of the current count. So at this position current count is 0 and maximum count is 3. Moving ahead, again we start the current counter. We got 1, 0 became 1. Now again we got 0. When we got 0, we stop iteration and we compare. Left side before updation, current count value is 1, maximum count value is 3. So maximum value is in 3 only, that is okay. And current count value we reset from 1 to 0. Moving ahead, current count is 0 before. Now we got 1, we increment it by 1. Again we increment it by 2. Again we increment it by 3. Again we increment it by 4. Now we successfully iterated from 0th position to n-1th position. That is all elements in the array. Now after iterating, current count value is 4, maximum count value is 3. For the last time, we compare and we return the maximum value, right? So we are comparing 4 and 3. The maximum is 4, so that we update the maximum count to 4 and we return it. So in the given array, in the given binary array is 4. Now let's see how to do this in code. In the given function max underscore cosec, we are giving the parameter integer array, that is nums parameter, that is the given binary array. Now we start with two variables. One is max count being 0, current count is 0. Now we start the looping. In the looping, we are running from 0 to n minus 1. If we encounter 1, we increment the current count pointer. If we encounter 0, we are doing two things. The first thing, we compare current count and max count and we give the highest value to the max count. And the second thing, when we encounter a 0, what we do in the second thing, we reset current count value to 0. Once we are done with the looping part, once we went through all the elements in the array, we again compare max count and current count and update the maximum value to the max count and we return it. As simple as that. I hope you understand this approach. If you have any doubts, then comment below. Now in the main function, it's just a binary array and then we are passing the binary array to the max underscore cosec function. Once we get the result, we are printing the result. As simple as that. Now let's talk about time and space complexity. As you already know, we are looping through the array only once. So the time complexity is O of n, where n stands for length of the given binary array. Speaking about space complexity, now we are not creating any extra space like arrays. We are just solving the problem in the given space. So the space complexity is O of n. The space complexity is O of 1. I hope you like this video. If you understand this video, like it, share it, and subscribe to our channel Get Placed soon. If you have any doubts, then feel free to comment below. Thank you so much for watching till the end.